Hey, welcome back to Molality, and we are on problem number 6, if you've kept up with your work. I'm going to go over a few problems here today. I'm not going to do them all, but I am going to hit a few things that are different and new, and let's just jump right in. We'll get warmed up here with number 6. Number 6, standard problem. No issues. You should have no issues with this. It does ask for mass, though, so let's see what it says. What is the mass of CH3OH is needed to add... let me read this again. What is the mass of C3OH? What mass of C3OH is needed to add to 1.2 kilograms of water to make a 3 molar solution? Again, we need to get these numbers in the right positions in the equation. So the first thing I'm going to do is I'm going to put those kilograms in there. And kilograms of water, of course, are going to go with the kilograms on our equation. And it just blocked me out, so I don't know what it is. There we go. So it's 1.2 kilograms of water. And then it said we have a 3 little m solution. So the 3 is going to go with molality. All right, easy as that. There shouldn't be any issues with these, I wouldn't think, right yet. All right, now that once we've done that, we're going to solve for the number of moles. I'm just going to pop an X in there. I don't know. You can do that if you want to. You don't have to. All right, so we have X on this side, and we're trying to solve for X. So we want to get the 1.2 away from there. So what do? We move it to the top of the other side. So we're going to end up with 1.2 times 3, and that equals 3.6 moles. So let's start there. 3.6 moles. Now, the problem doesn't ask for moles, it asks for mass. So we're going to have to do a quick factor conversion, and I'm just going to draw a quick factor labeled table to make things nice and pretty for us all. And the key to this is, of course, is to cross out your moles. Now we have a few different little rules that we use, but one of those rules is when you're factor labeling and you're using moles, the number that goes with moles is going to be 1. So that's our conversion factor. The other part of that is the mass is from the periodic table. The formula's weight from the periodic table. So we're going to go back and we're going to see what this is. So we have carbon, and there's right. Can you see it behind me? There's carbon. It's up there. It's 12. All right. Now you have a table in your. I'm sure you have a table somewhere on the internet if you want to, but there is a good table that we drew up, and it's in your folder. So you do have it in your Schoology folder. But we have 12 for C. Let's just punch that in the calculator. 12 plus 1 times 3. That's for the hydrogens. There's 3 hydrogens there. Plus 16. That's the mass of the oxygen. Plus 1 for that other hydrogen. It has a mass of 32. So we're going to pop in 32 grams up here, and we'll be ready to go. So look, I have 32 on my calculator. I know I have to multiply it, so I'm not going to erase it. I'm just going to put times 3.6 equals. And so I got 115.2. Oops, not 155.2. 115. Why is that not letting me type? Oh, it wants me to comment. Okay, let's see here. Okay, and there we go, and that's going to be grams. All right, not too bad, right? Very similar thing here. Only one weird little thing we have going on is right here. It says 400 milliliters of water. Well, they're assuming in this problem that you understand that the metric system is based on water, right? 1 milliliter of water, 1 milliliter of water is the mass of 1 gram. 1 centimeter cubed, it's a centimeter by a centimeter by a centimeter, is also 1 milliliter. So metric system did all of its masses and all of its volumes and things all related together and based on water. So what this really means is that is 400 grams of water. Now we don't want grams of water, do we? we want to have kilograms. So how did we convert to kilograms? We're going to move the decimal place 3 spots over. So it's 400 grams or 0.4 kilograms. I'll put the zeros for you guys who want to see the 3 spots. I moved it 3 spots. If you're not sure how to do that, you can factor label it. There's 1,000 grams in a kilogram. All right, so we have that all set up. In order to make a 0.6 molar solution, blah, 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 what is the mass needed to do that? Okay, so let's put our things where we know they go. First of all, let's put that 0.4 down here with kilograms. We worked so hard to do it, and we'll get it fixed right there. 0.6 little m, 0.6 molality goes right here. And we're ready to solve for moles. Remember, moles is the big in between, the middleman. So once we solve for moles, remember what we do? We have to, 0.4 is on the bottom of that fraction. We want to get to the other side. So 0.4 times 0.6 equals 2.24 moles. What are we going to do with that? We have to change it to grams. Draw a factor label table. Whoa, that's a very ugly factor label table. Let's try that again. We'll draw a factor label table. Take your time. Remember, 1 mole goes on the bottom. It's always 1 mole. And the mass is going to come from the periodic table. So I'm going to turn around and look at this table. Can you see it? Let's do this. What is it? It's K3PO4. Okay. I don't really have to look at the table. I'm doing this for you. K3, so 39 times 3, plus P. P is 31. Plus 04, right? So 16 times 4. And I got 212. All right, that was easy. That was fun. Yeah, good times, man. All right. Whoa, like that little cartoon peeking over the edge here. Okay, let's see if I can get my font in here. So 212. Remember, that's already in our calculator, so just times it by, I'm typing that on my computer, times 2.24. And I got 50.88. Let's call that 51. Oops, I guess I'm going to call it 50.9 grams. All right, now, I guess I've changed my mind. What? Okay, I'm back. I know I didn't seem like I was going very long, but I'm back. All right, so I've decided that I'm just going to solve all these problems out. Remember, you have the option. You don't have to keep watching. You can fast forward. You can do whatever you need to do to get these right. If you're not sure about one of the problems, skip to that problem. So that way we'll have it as a record so you can check it out. It'll be like a living key. So it'll make it nice for you. If you just want to watch the whole thing, then more power to you, right? Okay, so we're on number 8. Yep, number 8, and we'll get started on that. So though this time it says we have we have 4.5 grams of ammonium chloride, and it's added to 225 milliliters of water. What is the molality? Okay, this one shouldn't be too bad. Remember what we just said about that 225 milliliters of water. Now, I'm going to do it the long way. My phone just went out, so when it comes time for calculating, remind me. So this is 225 grams. I'm going the long way. So it's 225 grams. You don't have to type all that out. Or, because we need it in kilograms, it's 0.225 kilograms. All right. Remember, if we're changing it to kilograms, we move the decimal to the left. if we're changing it to grams, we'd move it to the right. All right, so there's our number that we need. All right, now, because I've already typed that so painstakingly, I'm going to copy it. And I'm going to put that down here with my kilograms of water. So there we go. So my water's in place. Grams of ammonium chloride. We need moles, right? So we're going to change this, this right here. We're going to change that many grams. Oh, it didn't change my font and stuff. That's fine. And we're going to convert that into moles. So let's go in I remember I have a straight liner. I'll use that this time to pretty it up a little bit. Draw a little factor label table. Remember, we're trying to figure out moles, and when you use moles, we're trying to make it moles. So we're going to put 1 mole, because it's always 1 mole on top, and on grams, it's going to be the mass of that thing on the bottom. So here's where my calculator needs to come into play. So I'll probably cut this out of the tell you on this, though. Yeah, there's our calculator. All right, so we're trying to find ammonium chloride. So that's NH4Cl. So N is 14. Remember, I'm just finding the weights off the table. H is 1, and there's 4 of them, so I'm going to say plus 4. And then Cl, chlorine, is 34, or 35. It's 35. And so I got 53 for that, so 53 grams. So it's pretty easy to do. The more you do those weights, I mean, I know most of them just by doing them, right? I've never tried to memorize them, it just happens. So this time, look, we're going to divide. So 4.5 divided by 53. 4.5 divided by 53 equals, oh, I got that number. Too bad I just can't copy and paste it off there. And so that should be my answer. Hopefully that matches. I haven't really checked the key, but unless I've made some little silly mistake, we know that these are right. I don't know where I'm going with the number of moles here, decimal places. You could have rounded that to 0.085, 0.08. If you get adventurous and you want to round it to 1, that's a guess. That's okay. That's pushing it, though. Or 0.1. Okay, now we have something a little bit different on this one. And let's read the question and we'll see what happens here. A solution of magnesium bromide is 1.4 molality. What is the molality of the bromide ions? Okay, this is not a problem. It's not a problem. The bromide ions, excuse me, they're talking about dissociation here. So remember dissociation? That's that word I like to say a lot. And you guys are like, what's he talking about? Yeah, that's the one. So dissociation is talking about the number of particles. So I want to say, let's say this is an Mg. Boom. And then we'll say that this is a bromide. Now look at the formula, MgBr2. Boop, boop. And so we have a bromide, or we have 2 bromides stuck onto an Mg. That's the magnesium bromide ionic compound. Well, once you put this in water, it splits apart. Remember dissociation? They split apart in little pieces. Remember I had the little water spheres surrounding them, the hydrospheres, right? So they're going to split apart. They're going to dissociate. So there are 3 different particles there that are going to split apart. So what does that mean? That means we have the 1.4 originally, but it's split into 3 pieces for each one of those. So the molality has been tripled. 1.4 times 3 equals 4.2. Okay, so they're just trying to make the point out. These are leading to a different type of problem, and they just want to make sure that you're able to see that. This only happens for ionic compounds. And if it's a polyatomic ion, like in this next one, right, that doesn't split into each atom. It stays with the ions, the aluminum and the nitrate, right? The things we name are the ions. So if they only have 2 names, they're only going to have 2 different types of ions for most things, at least what you'll see in here. What is the molality of ions in the solution if it has 2 moles? So they're going to make us do the problem. 2 moles of aluminum nitrate is added to 2.5 kilograms of water. So let's get this equation part done first, because you can only do this through the molality. Well, you can do it through the moles, I guess. But so we're going to put in for the water 2.5 kilograms. In for the moles, 2 moles, right? So we got that set up. What is the molality? The molality is 2 divided by 2.5, which is 0.8. So we have 0.8 little m. What is the molality of the ion? So let's look at this compound right there. We have 1 aluminum, and we have 3 nitrates. So according to my advanced mathematics, 1 aluminum and 3 nitrates equals 4 ions. So we're going to times that by 4. What did that do? Oh. So we're times that by 4. Let's just do it in the calculator because that's being stubborn. Times 4 equals 3.2. Okay. Well, it's not letting me do... Oh, I'm on the wrong thing. There we go. There's always a reason, right? 3 times 4 equals 3.2 m. All right. Moving right along. 2 more to go. Oh, 3 more to... 1, 2, 3 more to go. Okay. How many moles of ions are dissolved in 0.75 kilograms of water when the concentration of the ammonium phosphate is 0.4? So this time we're trying to find the moles. Now we have choices. Do we want to multiply before or after? It's not a tough choice because it doesn't really matter. It works the same way. So I'm going to do it afterwards because... why not, right? Why not? Gives us smaller numbers in the beginning. So we have this much water, so copy that water. At least we're doing it in kilograms and not milliliters right now, so be happy about that. And then we have our molality, which is the 0.4, and put that in the right spot. Make sure you get them in the right spot. Make sure you understand how to do this simple algebra. If you're not sure, send me the text through Remind and I'll go through it with you. Okay, so we have 0.75. We want to get that to the other side. It's on the bottom of the fraction. So that's going to be, oops, I tried to do that with my finger there. So we're going to put in 0.4 times 0.075. Oops. 0.4 times 0.75. And that equals 0.3. These problems are more fun when I have you guys here, because if I make a calculator mistake, you're there to tell me. And that's why it's so much fun when somebody tells you about your mistakes as you're doing them. Makes it so much fun. So there's your moles. Now we're trying to find out how many moles of the ions. So let's look at this thing. It splits up into 3 ammoniums and 1 phosphate, right? This should have been in parentheses. I can't put them in now, so that PO4 is phosphate. So there's only going to be 2 types of ions in almost everything you see. I mean, there are some cases where there's more than that, but for our class, it won't be more than 2. All right. So that's 4 ions times 4. It won't be more than 2 different types of ions. So 4 ions, so 0.3 times 4, that's 1.2, isn't it? Yep, it is, equals 1.2 ions, I guess. Moles of ions we could put. I don't know. The label's getting pretty specific here, isn't it? All right, we're rolling right along. Hey, I'm only at 12 minutes, too. So even if you watch me do all the problems, you're still going to get done within 15. Well, I might chit-chat it up a little bit and slow you down. So we have a solution of calcium nitrate must be 2m in ions. Okay, so they're getting a little tricky for us. It's 2m in ions. What is the mass that must be added to 125 grams of water? Let's do the grams first. Let's fix that first. That's grams of water, so that's going to be changed to kilograms. So what's our kilograms? We move the decimal to the left. It's 0.125 kilograms. Let's do that first. Let's fix the easy stuff. Do what you know first. Get it out of the way, and then you don't have to worry about it. Now, we do have to worry about this molality. The solution must be 2 molar of the ions. You know what we can do? We have options again. We can fix it, adjust it first, or we can adjust it after. So I'm going to adjust it after because I have the equation there, and it should be nice and pretty. So I'm going to put a 2 here. And then we'll go back and check and see if Mr. Arnold's doing it right, because this is new to me. So we're going to take the 2m times 0.125, and that equals 0.25. So wait a minute here. Two times 0.125 equals 0.25. That is right. So we have 0.25 moles. All right, that's the moles. That's straight out moles. Okay. And that's in ions. So that 0.25 is including all of the ions. That's including the Ca and the 2 NO3s. You see them? So there's a Ca and then 2 nitrates. So that's 3 ions. So that 0.25 moles is including those 3 ions. So we have to divide that by 3 because because the compound contributes 3 ions per thing. We're going to divide that by 3. And then we're going to go back and peek and see if Mr. Arnold knows what he's talking about. And I think it's going to be okay, though. This is not something I guess you could do this in class. We're not really going to worry about this too much. I got 0.083, and that would be moles of ions. No, that would be moles of the calcium nitrate. I'm going to peek. Oh, we went grams. What is the mass? Okay. All right. So we still have to go to grams. I'm sorry. Did I have to go to grams in this other one? I'm going to have to go back and peek and see. Okay, so we got to go to grams. So we have 0.083. And we're going to convert that into grams. That's moles so far, so moles. And let me make this up a little bit higher. Let me get my straight line. And let me draw my factor label. So I'm in moles. 1 mole on the bottom. Remember, it's always 1 mole in the factor label. And then on top is the mass of the calcium nitrate. So calcium is 40. Plus nitrogen is 14. And there's 2 of them, 14 times 2. Plus oxygen is 16. And look how many we have. We have 2 times 3. That's 6. So we have times 6 oxygens equals 164. So I'm going to put 164 up here. And then we're going to see what happens. Oh. This is... Okay. All right. 13.6. Oh, looky there. So we rounded ours. Something's rounded in there, but it all works out okay. Okay. One more to go. All right, we have 32 grams of sodium hydroxide. And it's added to water to make 500 grams of solution. Now, this is not legit. Okay, this is not legit because look at this. It makes 500 grams of solution. All right. Well, I shouldn't say it's not legit. It's a trick. Because it's not by the solution mass. It's by the water's mass. Okay, you ready? They're trying to trick me, but they're not going to. First of all, let's find how much water they added. So the total water was 500 grams. They put in 32 grams of sodium hydroxide. So let's take 500 minus 32 and equals, I'm sorry about this problem. If it wasn't remote, I'd probably make you skip it, but we'll do it. 468 grams of water. Right? That wasn't too bad. And then we have this many grams of sodium hydroxide. So remember, we have to fit the equation. So let's fit that equation. Move that decimal 3 spots over and put a K there. All right. We have the kilograms of water. We're halfway there. The problem's not hard. They just were being tricky. And then this last thing is that we have to find the moles. So we have 30 grams. And you might know this by now because I think we've used it so much in the last week or so, is that NaOH has a mass of 40. It's what we use for our experiment. I say we've used it a lot because remember I have to do those experiments 6 times a day and you only do it once. So I do all these calculations usually 6 times a day. So that's 40 grams. It's 23 plus 16 plus 1 equals 40. So we put grams on the bottom. We put 1 mole on top. And so 30 divided by 40 equals 0.75. I could have done that in my head. And so 0.75 moles is 0.75 moles divided by 0.468. 0.468, that is correct. And I got 1.6. I got 1.6. I know that I did that right. I bet you they did theirs wrong. Well, they would have divided by a bigger number. Okay, I won't chit-chat and waste your time with it. That's got to be right. So, yeah, unless it's 32 grams here. All right, here we go. Whoopsie, that's what I need you guys for. Okay, 32 divided by 40 equals 0.8. Let's put that here. I apologize to the key. It was my mistake. Can't believe it. And there's my 1.71. I thought that the key messed up on their own trick. But when you're using, remember molality. I'm going to stop talking because it's already too long. Anyway, when you're using molality, it's by water, not by solution. I promise I will not do that to you. And if I'd have read that one closer before I did it, I wouldn't have put it in there. Hey, have a great day. That's all those problems. Remember to submit that.